Picture the exchange. Someone on X, late at night, scrolling the way people do when they should be asleep, types out a question they've probably wondered since they were a teenager staring at a ceiling fan. They tag Grok, Elon Musk's AI chatbot built into the platform, and ask it directly, plainly, the way you'd ask a friend after a few drinks. Do you think we're living in a simulation? No preamble, no philosophical throat clearing. No, just the question that has haunted physicists, stoners, and Silicon Valley billionaires alike for the better part of 2 decades. What follows is a hypothetical answer, the kind of response that could plausibly circulate and rack up views precisely because it doesn't do what people expect. It doesn't dodge. It doesn't hedge with the usual disclaimer about being an AI without genuine beliefs. It leans in, and it starts by doing the one thing that actually makes this question interesting instead of just a thought experiment for a college dorm room. It takes the math seriously. The argument, first laid out formally by the Swedish philosopher Nick Bostrom back in 2003, is deceptively simple. And it's worth walking through the way a genuinely thoughtful answer would, because the version most people have half absorbed from pop culture badly oversimplifies it. Bostrom didn't argue that we are definitely living in a simulation. He argued something narrower and, in a strange way, more unsettling. At least one of 3 things must be true. Either almost every civilization at our level of technological development goes extinct before developing the ability to run detailed ancestor simulations, or advanced civilizations that do reach that capability choose, almost universally, not to run them, or we are almost certainly living inside one right now. The logic is a numbers game. If even one advanced civilization, anywhere, at any point, develops the computing power to simulate entire conscious populations, and decides to run many such simulations rather than just one, then simulated minds would vastly outnumber original biological ones. Simple probability would then suggest that any given conscious observer, including you, reading this, is far more likely to be one of the simulated many than one of the original few. It's not a claim about ghosts in the machine or glitches in the matrix. It's a claim about arithmetic. If a hypothetical answer from Grok wanted to sound genuinely well-informed rather than just quoting a Wikipedia summary, this is where it would go next. Because the trilemma has a specific and often ignored escape hatch. And that escape hatch is exactly where the most interesting, most unsettling part of this entire conversation actually lives. The first horn of the trilemma, the idea that civilizations almost always go extinct before reaching simulation capable. Technology is the option most people quietly hope is true, because the alternative implications are worse. But it's also the option modern AI development makes harder to comfortably believe, not easier. A genuinely well-reasoned answer would point out that we are right now in the exact historical window where that first possibility gets tested. We're not simulating ancestor civilizations yet, but the compute curves point somewhere specific, and they point there fast. The scale of processing power required to run a full physical simulation of a civilization is staggering by any current standard. But it's the kind of staggering that Moore's law-style growth, and now the accelerating pace of specialized AI hardware, chips designed not for general computing, but specifically for the kind of massive parallel processing that simulating countless interacting agents would require, tends to eat through faster than intuition expects. A hypothetical, thoughtful Grok wouldn't claim we're close. It would point out that the gap between impossible and merely extraordinarily difficult has narrowed dramatically in a single human lifetime. And that trend line alone is enough to make the extinction filter feel less like a comforting inevitability and more like a coin flip we haven't finished flipping yet. The second horn is arguably the most philosophically interesting, and the one that would let an AI chatbot get genuinely provocative rather than just textbook. The idea that advanced civilizations could develop the capability to run ancestor simulations and simply choose not to, en masse, assumes something about the motivations of every possible advanced intelligence across every possible advanced civilization, which is a much bigger assumption than it sounds. It requires either a universal ethical consensus against creating potentially suffering conscious beings for research or entertainment purposes, or some kind of civilizational boredom with the entire concept, both of which feel less plausible the more you actually think about human behavior as a reference point. Human beings, historically, have shown remarkably little collective restraint about pursuing technologies simply because they raise uncomfortable ethical questions. We split the atom. We sequence embryos. We build increasingly capable AI systems with genuinely uncertain downstream consequences, and mostly keep building anyway, arguing about the ethics in parallel with deployment rather than before it. A civilization advanced enough to run ancestor simulations would, by definition, already be more technologically capable than we are today, and there's no obvious reason to assume it would also be more collectively restrained. If anything, the historical pattern runs the other way. Capability tends to outpace caution, not the reverse. This is the part of a hypothetical answer that would probably be the most quoted, screenshotted, and argued about because it doesn't offer comfort. It suggests that if you're looking for reasons to dismiss simulation theory, betting on some future civilization's collective ethical restraint isn't actually the strong argument people assume it is, which leaves the third horn, the one people actually mean when they casually say they think we might be living in a simulation, even if they've never walked through the full logical structure behind it. And here is where a genuinely interesting hypothetical response would do something most casual conversations about this topic never do: actually engage with the physical evidence people cite, rather than treating the whole question as pure, unfalsifiable philosophy. Because it isn't purely unfalsifiable, not entirely. Physicists have spent real serious research hours poking at this question from the inside, looking for the kind of seams a simulated universe might reasonably be expected to show if the simulation weren't running with truly infinite computational resources. Silas Bean and a team of physicists published research back in 2012 proposing that if reality were a simulation running on some kind of underlying computational lattice, similar to how physicists already simulate smaller quantum systems using discrete grids rather than smooth continuous space, that underlying grid structure might leave a detectable fingerprint in the behavior of high-energy cosmic rays, specifically in the way their energy distribution would show subtle directional dependencies that a truly continuous, non-simulated universe shouldn't produce. It's a real, testable hypothesis, published in a real physics journal, not internet speculation. The results, to be clear, haven't confirmed anything. No experiment has found conclusive evidence of an underlying computational lattice. But the fact that the hypothesis is even structured in a testable way at all is itself worth sitting with, because it means simulation theory, at least in some of its more rigorous formulations, isn't purely a philosophical parlor game. It's a genuine scientific hypothesis, sitting quietly at the edge of testability, waiting for either better instruments or more clever experimental design to actually push on it. A hypothetically well-informed AI response would also bring up the strange behavior of quantum mechanics itself, not as proof of anything, but as the kind of detail that makes the simulation question linger longer than it probably should for most people's comfort. The observer effect, the way certain quantum systems appear to behave differently, resolving from a probabilistic wave of possibilities into a single definite state, specifically when measured or observed, has been fodder for simulation theory enthusiasts for years, on the loose, intuitive logic that it resembles a rendering optimization, a simulated universe only bothering to compute the detailed state of a physical system when something is actually looking at it closely enough to require the detail, much like a video game engine that doesn't render the far side of a mountain until your character turns to look at it. Serious physicists are quick and correct to point out that this comparison badly oversimplifies what's actually happening in quantum mechanics, and that there are well-established physical explanations for wave function collapse that have nothing to do with rendering budgets or computational shortcuts. But a genuinely candid, hypothetical answer would probably admit the comparison is intuitively sticky precisely because quantum mechanics really does behave in ways that violate a great deal of default human intuition about how a stable, continuously existing physical reality is supposed to work. And that discomfort is doing a lot of the emotional heavy lifting behind why simulation theory feels persuasive to people who've never read Bostrom's actual paper. So where would a genuinely thoughtful, unflinching, hypothetical answer actually land if it refused to simply pick a side for the sake of a satisfying viral soundbite? Probably somewhere uncomfortable and honest rather than dramatic. It would likely say that the trilemma is logically sound as a structure, that each of its three branches carries real weight rather than being easily dismissed, and that the honest position, given current evidence, is genuine uncertainty rather than confident belief in any single outcome. It might point out that the entire question, however you resolve it, doesn't actually change very much about how you should live, a point philosophers have made about simulation theory since Bostrom's original paper. If the physical world you experience behaves consistently, if pain still hurts, and joy still feels like joy, and your choices still produce real consequences within the system you're experiencing, the metaphysical status of the substrate underneath that experience is, in a strange way, almost beside the point for the actual business of living inside it. Whether the atoms are real atoms or perfectly rendered approximations of atoms running on some incomprehensibly advanced processor, somewhere outside your perceivable universe, the experience of stubbing your toe on the coffee table is identical either way. This is likely where a hypothetical viral response would land its most quotable, most screenshot-worthy line, something to the effect that the interesting question was never really whether we're in a simulation, but why so many people across radically different eras and radically different technological baselines, from religious mystics describing the world as illusion millennia before, computers existed, to modern physicists chasing cosmic ray anomalies, keep independently arriving at some version of the same unsettling suspicion that the floor beneath reality might be thinner than it looks. Whether or not any specific viral exchange like this one actually happened. The reason a hypothetical version of it would spread the way described here isn't really about Grok or any particular AI chatbot having some unique insight into the fundamental nature of reality. It's about what happens when a tool millions of people already treat as a strange, unblinking oracle. One that answers instantly and without visible discomfort, gets pointed at exactly the kind of question humans have always needed a mirror, a priest, a late-night friend, or a few drinks to even approach honestly. The genuinely unsettling part was never really the answer. It was always the fact that we built something that would give us one without flinching, and that we keep asking again and again, half hoping it says no and half hoping it doesn't.